Hi everybody, and welcome to the Sky Carl Weather Report. Now I'll tell you what, today it's cold, cold, cold. And you know what, one of the things that's causing that? It's the polar vortex. The polar vortex? What is that, do you say? And what could that possibly have to do with my weather? Well, that's what we're going to look at. Today we're going to look at what this polar vortex thing is, and why do we have like these low pressure areas that bring in storms? Where do they come from? It's like one day the map is clear and the weather's great. The next day you see these like little L's with a circle around them, and the meteorologist is talking about this low pressure area, and it's bringing in rain, or it's bringing in snow, or it's bringing in whatever. Where did that thing come from? It just out of the blue. How did low pressure get there? So that would cover that a little bit today too. So let's get at it, and we're going to go from here, and I'm going to take you to some illustrations, some graphics that we can take a look at a little bit better and get a better handle on it. So let's go to there.
Okay, as we know, the way the Earth sits, that the rays of the sun hit the center of the Earth, which is what we call the equator, dead on, directly on. And its rays are the warmest there, they work the best there. And that creates the water to get really warm, and that creates the air to get really warm also. At the same time, up the polar areas, both the north and the south, the rays hit it at an angle. And when it hits it up there, it is not as intense. The heat does not hit directly on it, and so it stays cooler. So that's why that's the colder area of our planet. Now here in the northern hemisphere of planet Earth, when we see water go down the drain, if you ever watch it, you'll notice it goes counterclockwise. And why does the water go down the drain? Because the pressure when it's released and there's air, there's the air is lower in pressure than the water itself, so the water falls to the lower pressure, and that's what happens with air. Air goes from a high pressure to a low pressure, just like water running downhill. It does the same thing. There's more pressure above than below, and so it will flow. And because the way the earth and all that, with all that stuff we're not going to get into, up here in the northern hemisphere it spins counterclockwise, southern hemisphere it spins clockwise. So cold air has a tendency to fall. Hot air has a tendency to rise. So when the cold air is falling, it turns counterclockwise. So when we look at up in the polar region where the sun was not beating down hard, and so it gets a lot colder up there, and that air gets colder up there, it spins counterclockwise, and so does the polar vortex. Now, let's break that down. Polar vortex. Polar because it's in the northern pole area of the Earth, and vortex. Well, that water as it spins around going down the drain, that's the drained vortex. When you watch a tornado and you see all the debris field spinning around, that thing spinning around is the tornado vortex. So the vortex is the thing that's spinning around the low pressure. So that is our polar vortex. So now, uh, as the polar vortex spins around, we get these little areas of low pressure, these little areas of cold air and low pressure break off and go spinning, uh, out and about. and they break here and they break there, but they have their low pressure areas. And now that's one of the ways that you get a low pressure area. There's other ways of getting it too, and that has to do with the highs, the high pressure, which is something that we're going to cover here in just a second. Okay, so now we'll just touch a little bit on high pressure. And please remember all this stuff that we're covering here. This is like real super basic stuff, and we're not even we're just at the tip of the iceberg. There's so much more going on, but I'm just trying to give you a rough idea of kind of what's happening. Okay, so we have all this warm water. Remember we talked about it on the equator that's been heated up by the sun. And at different points, there'll be like these bubbles of warm, moist air that kind of lift up and they head up and they start heading kind of towards the pole. And as they do that, the higher they get, they start to cool down and they start to lose some of their moisture and stuff. But they still have a weight to them, and they come down and they put that weight on the atmosphere, and it kind of creates like a bubble in the atmosphere. And remember how we talked about the low pressure areas go counterclockwise, high pressure goes clockwise, and once again that's in the northern hemisphere. But this high pressure, as it spins clockwise, it can have a great effect on the things that are going on around it. Like you have like warm, moist air that's being brought up from the Gulf, and if it hits a high, it will ride around the west side of it, because the west side is going from bottom to top clockwise. So if that by that passing, it could easily pull moisture up as it goes. And a lot of times you'll see how we'll get all this big mass of moisture that's being pushed from like the lower states, Louisiana, Mississippi, even Florida, and it's being pushed up north. That's usually being pushed up by a high that's spinning and pushing it up. Matter of fact, here's something just to think about. Sometimes you'll have these depressions coming off of the coast of Africa, and they're out into the Atlantic spinning. They're a low pressure, and if they get a high pressure area near them, that high pressure can spin moisture and warm energy into that tropical depression and give it energy and let it intensify, and eventually can turn it into a hurricane, and that can be helped by a high pressure area. So I think right here we'll kind of like hold it right here for now, and because we don't want to get too far into it. This way we can like kind of think about this, and then as we go along we can add to it and get a little bit more involved and a little bit more complex.
Okay, everybody. Well, I hope you really enjoyed our little explanation of what some of these weather things are. Uh, I hope it helps you understand a little bit more of what's going on in your weather life. So until then, I want to say thank you so much for watching. If you enjoy this and all the other things I do, and the fun we have here, please hit the subscribe button. And if you like what you're watching, click the thumbs up and the like button, because that really does help. So until then, everybody, take care, and I'll see you in the next video. Bye.